Hello friends, I am Trupti Singhal from the career classes. In this lecture, we solve the question 2 from the exercise 1.1, chapter 1, real numbers. Let's get started. The question is, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. I am highlighting some words. Why? I am telling you later. But let's we solve on basic numbers. So I take the sum of the odd positive integers like 1, 3, 5, 7, 9, 11 and so on. So when I divided these odd integers by 6, why I am dividing by 6? Because we have to show that it is of the form 6q plus 1, 6q plus 3 or 6q plus 5. At the place of b, divisor here given that 6. That's why I am taking the 6. So when I am dividing the odd positive integer by 6, what I get as a quotient and remainder? So I get the quotient as a 0 and remainder as a 1. When I am divided 3 by 6, as you know all, the quotient is 0 and the remainder is 3. When I divided 5 by 6, the quotient is 0, the remainder would be 5. Again, if you see, in the case of 7, when I am dividing the 7 by 6, 6 ones are 6, the remainder would be 1. Naturally, for the 9 also, 6 ones are 6, remainder would be 3. For the 11 also, 6 ones are 6 and remainder would be 5. So, what you see, the same pattern in all these cases is A, this all the numbers would be A, positive integer, and this is the 6 divisor B, and this is the place of Q, quotient, and most important thing is the R is only of the form 1 or 3 or 5. Again 1, 3 or 5. That is nothing but the our remainder. So we see that in all the cases when we divide any positive odd integer by 6, we get only of the form A is equals to 6q plus R. Okay, and R would be of the form 1, 3 or 5. That means it would be 6q plus 1, 6q plus 3 or 6q plus 5. Now let's get started the solution. This is not a part of a solution. Just simplify solution. Start. Let A be any positive odd integer. Why I am taking odd integer? Because here says that A be any positive odd integer, B is equals to 6 divisor. So by Euclid division algorithm, we get A is equals to big Q plus R, where this is the condition of R, 0 is less than or equals to R is less than B. Okay, now put the value of B is equals to 6 in the Euclid division algorithm. So what we get? A is equals to 6q plus R, where 0 is less than or equals to R is less than 6. So friends, when I take this condition 0 is less than or equals to R is less than 6, that means R takes the value between the 0 also and less than 6. That means it takes the value 0, 1, 2, 3, 4 and 5. Because the condition is given that R is less than 6, but it could be greater than 0 or equals to 0. Therefore, I take the values of R like this. On the basis of this R value, we have A. A is equals to 6q plus R. Put the value of R is equals to 0, R is equals to 1, 2, 3, 4 and 5. So we have this 5 numbers. So now you can see we assume that A is any positive odd integer. So odd integer, that means you all know that odd integer are those numbers that would be not divisible by 2. So we can see 6q plus 1, 6q plus 3 and 6q plus 5 are not divisible by 2. That's why we take only A is equals to 6q plus 1, 6q plus 3 and 6q plus 5 as a odd positive integer. And therefore, we can write that A should be, so any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Okay, is it clear? Yes. So it's a pretty much cool. The question is 6q plus 1, any positive odd integer is of the form 6q plus 1, 3 or 5. Now the question 3 is most important, the question for chapter 1, because it is the word problems on the basis of finding the HCF or LCM. So let's get started. Question 3. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. So what is the maximum number of columns in which they can march? सो फ्रेंड्स, जब भी हमको कुछ मैक्सिमम फाइंड करना होता है, जब भी हमको कुछ सेम नंबर्स के लिए फाइंड करना होता है, देन वी अप्लाई द HCF ऑफ द टू नंबर्स, देन वी ओनली फाइंड द HCF ऑफ द टू नंबर्स. Why applying the HCF? Because the HCF itself says that the highest common factor, highest, whenever we wish to find the highest commonly between the two numbers, we have to find the HCF of that two numbers. Here 616 the army members and 32 there are the army band members. So they two groups are to be marched in the same number of columns. And what is the maximum? Okay, maximum number of columns in which they can march. So that's why we apply the HCF of the two numbers. So and we have a method for finding the HCF is nothing but the Euclid division lemma. So by applying Euclid division lemma on A and B, our A and B is 616 and 32. Therefore, we have 616 is equals to 32 into something plus remainder. Okay, we just fill these two numbers, quotient and remainder. So whenever we divide the 616 by 32, what we get, the quotient is 32 ones are 32. Okay, so it is a 29 and 296, it would be 296. So we know that 32 nines are, we apply 32 nines are 288. Okay, so we get 16 minus 8 only 8, the remainder is a 8. So we put the value simple, we put the value, the quotient and R, because we know that this is nothing but the Euclid division lemma, A is equals to B into Q plus R. Okay, so do we get the R is equals to 0, sorry, R is remainder 8, so do we get R remainder is equals to 0? No, then continue the process till we get R is equals to 0. So again applying the Euclid division lemma on B and R, on which two numbers? On these two numbers B and R. We have to apply again these two. So we have 32 is equals to 8 into the quotient and plus remainder. So we all know that 8 fours are 32 and remainder would be 0. So bingo, we get the remainder as a 0. So at this stage we have the HCF is a B. B is our HCF at this stage. That means at the stage when we get R is equals to 0, B is our HCF. Therefore, the HCF of 616 or 32 is equals to 8. Or we can say that the number of columns is 8 in which the two groups can March. So thank you. Keep learning.